Alright, in this section we're going to be learning about the measure of spread of data, which we actually call that something different. So when we're looking at a set of data, we're going to have variation within that data, and usually it's talking about how concentrated or how spread out it is away from the mean. Okay, it's always talking about the mean, concentrated closely near the mean, or is it spread out from the mean? Okay, the most common measure of variation, which you can say variation is the same thing as spread, they're used interchangeably, but the most common measure of variation or spread is standard deviation. And that's what we're going to be looking at today, is what is standard deviation and how do you calculate this thing. Okay, so standard deviation, it is a number, and it's going to tell you how far all the values are from the mean. So it's going to take every single data value that you have within your data set and use all those numbers to produce one number, and that number will tell you what is the variation within that data set. Okay, so what I just said uses every single value within your data set, or the overall amount of variation in your data set. And like I said, it's going to tell you how close or how far all your data values are from the mean. Okay, said these two already. Now your standard deviation is either going to be positive or it's going to be 0. It's never going to be a negative number. And it's only 0 when all your data values are exactly the same. So if I have a data set that has a bunch of 5s, well, when I look at this data set, is there any variation within this data set? Well, no, it's the same number, right? They're all 5s. So since there's no variation within this data set, and the standard deviation measures variation, well, then the standard deviation is going to be 0 because there's no variation within this data set. Okay, now your standard deviation is going to be small when your data value is really close or concentrated to the mean. So that means that you have little variation or little spread. So if you got little variation or little spread, then that means that your standard deviation will also be little, or it will be small. So they go hand in hand with each other. On the flip side, if your standard deviation is large, well, then that means that your data is going to be more spread out from the mean, which means that you'll have more variation. Okay, so more variation or more spread means you're going to have a larger standard deviation. And like I said, standard deviation takes every single number within your data set, and it's going to use all those numbers to produce one number, that's standard deviation. So if you've got an outlier within your data set, your standard deviation is going to be affected by it because it included that outlier in the calculations, just like the mean does. And if all your data values were in feet, say you're taking the height of everybody, well, then your standard deviation, the number that you get for the standard deviation, will also be in feet. It has the same unit as the original data. Okay, if we look at the graph of, this is a normal distribution. This black line here in the middle, that's always going to represent your mean. And these are, you have more data value here. The higher this goes up, the more data values you have here. So I have a lot of data value around my mean, and then it gets smaller, less data value, less data value over here, same thing over here. So if this is my mean, and I look at this data value right here, notice that they're pretty close to each other. If I look at the overall spread right here, it's pretty little. They're pretty close to the mean. All your data values are pretty close to the mean. So little variation, small standard deviation. Here's your mean. If I have data values way out here, they're pretty spread out far away from the mean. So large variation, large standard deviation. Okay, so if this is A right here, B is kind of in the middle, and C is the longer stretch here, which distribution has the most variation, A, B, or C? Well, since C goes from here all the way out to here, it has the largest spread. That's got to be C right here, the most variation, which means its standard deviation is going to be large because it has the largest spread. Well, which one will have the least variation? Well, it will be the shortest one. B goes from here to here. A goes from here to here. So the shortest one is A. And its standard deviation is going to be small. It'll be the smallest one out of these three. Okay. Now before I move on to the next slide, don't freak out. These are the formulas used to calculate the standard deviation. Okay. They look worse than what they actually are. Ready? There it is. Okay. Now we've got two things going on here. If we are looking at the standard deviation from a sample, we've got two options. Okay. Now it looks like this one is easier to use because it looks less scary, but it's actually not the best one to use. You actually have more chance of making an error in this one than you do this one. This one is actually a shortcut, believe it or not. Okay. So for the sample, you've got two choices. I would go with option number 2. If you're looking at the population, well, you've only got one choice right here, and that will be this formula right here. Now, if we are looking at the standard deviation from a sample, the way to represent it is with an S. Okay, this represents right here, instead of me writing out sample standard deviation, we just say, okay, that's just S. If we're looking at the population standard deviation, we're going to represent it with a Greek letter, and we call it sigma. Okay. Now, if we find a number from the sample for the standard deviation, the first thing that we want is that number that came from the data set. We want that data set to have all the characteristics from the population. Because remember, we want the sample and the population to look just like each other, the sample just being a smaller version of the population, but both of them having the same characteristics within the data set and the population. Because all we're doing is we're looking at the sample, finding out stuff about the sample, and using that to apply back to the population. Remember, that's called inference. So we want our data set to look just like our population, so that the sample standard deviation that we get from our data set will be a good estimate for our population standard deviation. Okay, now X, oh, by the way, let's go back. This X right here, that is a data value, just one data value. This X bar here, that is your sample mean. This lowercase n, that is your sample size. And the only new thing over here is this right here, the symbol. That just means add everything up. Okay, now down here, the same thing. That's a data value. This is your population mean. And then this right here is your population size. Okay, now if we look at X minus mean, or a data value minus the mean, that is called a deviation. So you're going to use, say you had this data set. So 1, 2, 3. Okay, each one of these would be an X value. So I would find the mean of this, and I would do 1 minus the mean, 2 minus the mean, 3 minus the mean. Each one of those would be a deviation, which you see a deviation right here. Here's a data value minus the mean. Here's a data value minus the mean. Each one of those is called a deviation. So I had 3 numbers in my data set. So I would also have 3 deviations. There are as many deviations as there are items in your data set, because you're taking each one of those data values and subtracting them from the mean, and that's called a deviation. Okay, now this is just a symbolic difference right here. This is right here. That's just talking about the mean, or sorry, the population standard deviation, or sorry, mercy, the population mean. This right here is talking about the sample mean, but both of these are the same thing. Okay, they're talking about a deviation. It's just whether did it come from a population or did it come from a sample. Okay, so you're going to have a positive deviation when the data value is greater than the mean, a negative deviation when the data value is smaller than the mean. And here's the weird thing. If you add up all the deviations, the sum of them is always going to be 0. And we're actually going to use that to check our table for making or for finding the standard deviation. Okay, variance the average of the square of the deviations. There's actually an easier way of explaining this, because that sounds actually really confusing. Okay, the units of variance are the square for the units of the original data. So if we were looking at feet, then variance would be feet squared. Okay, now variance is the same thing as a standard deviation, meaning that it takes into account every single data value. So it will also be affected by outliers. And just like the standard deviation, it will never be negative and only 0 when all the data values are exactly the same. Okay, so remember that we represented the population standard deviation with sigma. Now, for variance, the symbol for, if it came from the population, is sigma squared. And for the sample standard deviation, we represent it with an S. Notice if the variance came from a sample, we say it's S squared. So really, what we're talking about is if I square the standard deviation, that gives me variance. If I have variance, then if I square root that, then it'll give me back standard deviation. Okay, so if I have variance and I'm trying to get to standard deviation, by the way, that's not STD, that's a whole different class. This is standard deviation. That should be deviation right there. Okay, if I have variance and I'm trying to get standard deviation, to go from one to the other, I would have to square root that number. And if I had standard deviation and I was trying to get back to variance, what I would have to do is square the number that I have. Okay, so I can go back and forth between variance and standard deviation all day long. Okay, they're kind of connected to each other. Okay, so like we said, sigma squared is talking about the population variance, and S squared is talking about the sample variance. And sample standard deviation, S is the square root of the sample variance, just like we were talking about right here. Okay, you can go back and forth. Okay, let's look at our first example here. So we're going to find the standard deviation of the population. That's going to be important. 2, 5, and 8. So all of these are my data values right here, 2, 5, and 8. And I only have one formula for that, which is this right here. So the very first thing I need to do is find x minus the mean. Okay, well before I do that, I need to find what is the mean. And since it's a population, the population mean is going to be mu. So I need to take 2 plus 5 plus 8 over 3. So 15 over 3, or 5. So I'm going to take all my data values and I'm subtract each one of them from the mean of 5. So that will give me -3, 0, and 3. Now remember, a data value minus the mean, this is called a deviation. If we add all these up, it's supposed to come out to 0. So this is kind of like a checkpoint. So -3 plus 0 plus 3, the summation of that does come out to 0, so we're fine. And then last thing is, for this table, is I'm going to square each of these numbers. So 9, 0, and 9. Okay, because of the square right here, that's why I squared each one of these. Last thing to do in this right here on the top is add them all up. So this would be the summation of x minus mu squared, which 9 plus 9 is 18. Okay, so that's the top number, is 18. The bottom number is how many data values I have. Well, I have 1, 2, 3 data values. Okay, so that's going to give me the square root of 6. Plug and chug that into my calculator, and I'm going to go to 2 decimal places. 2.449. So this is going to be 2.45. Okay, so that's my final answer right there. That is the overall variation from the mean for this data set right here.